Recording is on.
Sorry, I'm late. Thank you. Can everybody hear me?
Loud and clear.
Yes.
Excellent. Okay, let's start this Tuesday, February 5th, 2 p.m. CST USA time. Hey guys, so just actually had a late night this night. You see it on my face, but we're actually shipping a brick press down to Belize. My biggest news. So I've been working on the controller and the brick press. Scott Mayer, who's American guy, but he lives in Belize. We're taking the brick press down there, so he brought one of his people from Belize, and we are going to build there. There's a workshop being planned probably for around November time, and that's actually pretty exciting because we're going to see the brick press in use, as in real people's homes. So basically setting up production in Belize so that it can serve, first of all, build there's one planned house already, but then start pressing bricks for the community around there. So just a great opportunity, and it would probably be an international workshop, just like people have been coming to our place from different countries. This will be a great chance, and there you have a little bit of better weather and coral reefs. So that's from the natural point of view in the tropics in Belize. So yeah, that's what I've been doing last night till late. There's a person who's a builder, kind of jack of all trades, civil engineer, who actually is driving the brick press down to Belize as we speak right now. So it's pretty exciting. So we'll see what happens with that. So whoever met Scott, Scott's a great guy. He's been here for many workshops, including the build of a couple of brick presses, the house, a lot of the house builds. So Scott's a great supporter, and look forward to seeing that evolve. If you look at, let's see,
cool.
Yeah. Let's see it just to show you the latest on a controller, what the final product looks like. Let's see, it's probably let me share my screen here. Do we have it? Let's see. That's my sleeping patterns. No, he's not there yet. Let's go into the photos. That's the for anyone who hears that. I took the controlled machine to the Detroit. Here's what the very final deal body. Look at this. Super simplified over work before. So what you see here essentially is the heart of this is the Arduino Mega, which is the same thing as on our 3D printer. And on top of that is this 4-channel relay shield. And that's driving the hydraulic solenoids on the brick press. And the interface is simply an on-off button. Button is like right there at the bottom. And a selector switch, 0 through 5, 0 through 4. 1 through 4 are the different brick thicknesses from full to half. So you're still, and 0 is basically reset. So if the machine ended up in whatever position, it resets it to its original place. The logic in a brick press works by a single pressure sensor, and what you see here is on a relay shield, a single 6-pin DuPont connector. That's basically four wires go to the switch plus a ground, and then 2 wires go to the pressure sensor, and a single pressure sensor controls all the logic. So the way it works is it measures the time of motion for the secondary drawer cylinder, and based on known geometries, you can time everything from that. So for example, when you close the compression chamber by moving the drawer to a certain position, that's perfectly timed, and it's actually very reliable. You take a multiplier of the drawer extension time for that, and it's close to within, like, a couple of millimeters every time, so it's very much reliable. And also the brick thickness is selected by timing the time from the very top to how far you drop the cylinder, so that determines how much soil you load. And that's also timed by the logic. And the timing logic is basically you start at the bottoming out of the drawer cylinder, you go to the max, and at both points you have a peak of pressure. So it's basically high pressure event at the beginning and the end of the stroke. And then you're just measuring the time within the code. So you can take a look at the code, how that does that. But it's a couple of lines. It turns out that logic to implement all this kind of stuff is, when you get down to it, a lot of times it's pretty simple. But that's what it looks like. So here's that. So here's the actual, some of the mechanical system, the guide rails. This is 16.09, and Scott had it here for few years actually, and we were using it here as well. That's kind of how it looks like in cold weather. It was kind of brutal actually out there, but that's the system. You see the relays there. And actually, yeah, that's the way it kind of looks, with hose protectors on the hoses so you don't wear out the hoses. So yeah, that's about it on my side here. From here on, the next thing that's happening for me is doing a workshop on a 3D printer build that's actually next Monday at a local school in Kansas, Highland Community College. So now shifting back to the 3D printer and working out the kits and marketing, including the potential there that I mentioned last week of licensing to for some people in China from the Shenzhen Open Innovation Lab. That's happening. We'll see how that goes. But yeah, focusing on the printer, getting that, including the prototype we built last year was a 1 meter giant printer, 1 meter bed. I'm going to get back to that and work that out. That should be quite exciting, actually, because larger printers are much more valuable. You can print larger things. So that's where we are. So main update here is brick press, and then back to 3D printer. Yeah, good stuff. So exciting things. Yeah, so can the next person come in and report?
Questions on the prep.
Yeah.
I saw that you were working out the timings on the code and all that, and I know there was a bunch of delays you had to add, obviously, just because the switching speed is whatever it is, which is pretty fast. But I think the one thing that I did notice was an issue was that you pointed out that there was certain times where the condition for the pressure sensor test was simply failing to check because the signal was poor. All I did that the last code was add a another function call into that function to recursively kind of call itself at one point whenever it fails, I think the second time. So I didn't know if that was good or if that was likely to test out as maybe causing too much variation in the, it would add extra delays and maybe not consistently.
Right. Yeah, and that's on your GitHub code.
Yeah, that's on the
Yeah, so there were
GitHub.
actually. I did not look at that actually, and that's because there were actually other concerns that were pressing above that. So the difference in this brick press is actually that instead of using, let's see, let's go back. So these solenoids here, let's see. So here's some more pictures of just going through that, and that's the old board. There is a difference that I want to point out, and that is that, and I mentioned that before, we are using valves that are motor spool valves, okay? The explanation for that is, for this same kind of a valve on this small, it's called a D03 base plate on the back there, those valves here shown are motor valves. What that means is that there's, as opposed to cylinder valves with the cylinder in place, motor valves, the way they're structured, cylinder in place, and the cylinder is able to drift. Because of that, I had to modify the code. So for example, to give you an example, you lower the main cylinder, you press the block. When you finish the actual active pressing, there will still be remaining pressure on the pressing on a block, because the ports to the big cylinder are both open. Both the top and bottom ports are still open. And because you have a rod in a cylinder, the pressure at the bottom port will tend to make the cylinder go up, because it has the full surface area of the cylinder piston, as opposed to the other side, which has the rod, which removes surface area, and therefore there's a differential pressure, meaning the cylinder will go up. What that meant is that after the brick was pressed, you can't just open the drawer, open the compression chamber, because that cylinder will, the main cylinder is drifting up. So what that meant, I had to put an artificial further downward motion on the main cylinder to allow the drawer to open. Otherwise, it would just lock up, the pressure would go high, and things like that. This is different than what we've seen before. So there were issues like that, and I ended up having to, in order to address that fully, had to add a longer delay, and it turned out to be actually 900 milliseconds after the pressing. What that means is that we're losing almost like five seconds every minute on just that step. Not too bad, but given that each brick is pressed in about 10 seconds, we're losing like half a brick per minute. But anyway, the idea there was there were issues of the drift, cylinder drift, that were introduced for the sake of having more flow through the valves themselves, because the cylinder valves of this nature here, they only allow 10 gallons per minute, whereas the motor valves allow 16 gallons per minute. And the Power Cube that we're using, I believe that has 14 gallons per minute, so we wanted to work with a higher flow. So that's the deal. The drift issue made some complications in the code, which just had to be gotten rid of by just looking at when, how much do you have to release the main cylinder to make it not lock up and stuff like that. So there's a little goofing around there, and yeah, it's a little tricky. I mean, the freezing weather did not help. I think there were some effects that, we did press a few bricks, but we were struggling to get some dry soil, basically crushing up old bricks and reusing that kind of soil. So there's some complications with the freezing weather and stuff like that. So maybe like that delay there might have to be readjusted in the summer or something like that. But that's where we were. So didn't there was not an issue with the debounce part. With 50 millisecond debounce, everything worked well. So yeah, just
Okay. I think I read some of that. It looked like there was, differences eventually. What you were doing on the wiki looked a lot different than the code that you had updated to GitHub. And I did catch some of
Yeah.
that. I guess it's just different hardware. You think that hardware is a little better for the flow? You think that there's other hardware that might be better than that for future designs, or is that just the better solution for the flow rate?
There's better hardware, but it's basically at this point cost engineering. So if you use those small valves, that system ends up being about half the cost. Like, okay, so what are the valve costs? They're $110 for just the solenoid each, plus $50 for the base station. If you go up to the larger ones, which we used before, we used the ones that are rated for 30 gallons per minute. And well, given that we rarely used 30 gallons per minute, we used that maybe just a little bit, but in practice, it was typically sufficient to run one power cube, because for 30 gallons per minute, you're going to need 2 power cubes of the standard power cubes that we have. So we typically ran on one, and therefore, okay, we said, okay, until the point where we have massive production of block, which would be relevant for a brick pressing operation if you're selling them, for example. But for now, for regular builds, it was quite acceptable to have one power cube, about 10, 15 gallons per minute, because if you have the full power, you need like a dozen people just to like stack the bricks when they're coming off the conveyor belt. It's really fast. So with one power cube here, it's cost engineering using the smaller valves, which cost about $300 just for the valves. If you go to the much larger valves, that system may end up being close to like double the price. So not 300, but more like 600. And realistically speaking, the valves we got years before, they were more like 800, but that was still when we were using a set of 3 valves before we removed the hopper shaker. So approximately double the cost if you go to the much larger valves. And right now I source these. These are from Power USA or something like that, some Texas place. But they're sourceable quite readily. Like they're from a manufacturer that's not like a Northern Tool or Surplus Center or something. What I think is a reliable manufacturer at a decent cost. But if you talk about the small valves, if you want to enlarge that hardware so that you use cylinder valves as opposed to the motor valves, it'll be just double the cost is the idea. Now, what happens if you just use the cylinder valves, which are rated for 10 gallons per minute? Well, the 18 horsepower power cube will work reasonably well with that because, well, I mean, it's still going to be about 12 gallons per minute that we can have from that. So you're kind of like going over the specs of the valve, which means you get more heating. That's the issue there, and for which reason, if you can use the motor spool valves, which are up to 16 gallons per minute, that's a favorable thing for the same cost. Now, will it work to work that all out in the code by making the code just a little more complicated with the proper delays and proper like retractions to account for the slight drift? The way the cylinders, the pressing sequence motion, it allows it pretty concerned there being the time when after you press and then you're ejecting the brick, that point where you just have to put in a single delay there. That's I think is quite tractable, so that by a simple one line in a code, you enable the use of the motor spool valve. So I think it's worth it. And that's to be determined. I mean, we'll see. Like, I think the real arbiter of this will be how well this is pressing down in Belize. I think that's going to be a real use case where they're actually setting up somewhat of a facility where they've got a structure under canopy where they're pressing the bricks and so forth. So they're going to get a lot of use out of this, and we'll see how well it's working, and if that delay, or that 900 millisecond delay, if that's an issue, or if it can be smaller, or it can be larger. Well, smaller. You'd like it smaller because, as I said, with 900 milliseconds, you're losing a pressing rate of about half a brick per minute, which is not a lot, but it kind of does add up over time. It's like 30 bricks per hour.
I was wondering about the delays because they're fixed numbers in the code, kind of like you were saying about temperature and things like that, and maybe wear and tear over time on, if you try to make them real small, eventually if, relays and switches start to go out of spec or the signaling is worse, they may have to be adjusted frequently, or if, environment is that much of an issue.
Yeah.
And that's kind of hard to fix in the code, I think. I mean, you got to set the timing to something, and I mean, it can kind of calculate timing like we did a little before, I think. I think you just put fixed numbers those for the math that time, but and without a whole bunch of extra complications to the machine, like, I don't know, actual sensors of motion or something, I don't see a way to do anything more automated in the code. Other than if there's switching issues with like actually detecting the debouncing issue with the actual pressure sensor switch, I wasn't sure whether what I did there was good, or whether in general, at some point when we have a lot of machines like this that have a lot of switches and sensors that need debouncing, it looks like rather than trying to write some code that's fairly simple to debounce those things, because a lot of times just a repeated check isn't necessarily good enough because it has different ways it can fail. There are Arduino libraries that are already specifically written for this stuff, and they have some complexity, but they're designed to be easy to use, and they're well documented and fairly popular. So sometimes using that other code, it's all open source, I think. So using that kind of stuff universally might actually be a better approach when switches are not good enough. Because debouncing is a frequent issue.
Yeah. No, I think we're, I think number one is, let's see what the success rate looks like for the guys in Belize, for Scott and crew in Belize, and then we can make corrections. Good thing is that they're on board. They're, the guy that is going to be stewarding the machine, he's a civil engineer guy. He does heavy equipment, so he's quite familiar with a lot of stuff, and I think we're going to get some hacking happening here, so that's really good. So yeah, and let's see where it goes. I think like the only, in terms of features, like feature complete, I think just the brick counter little LED display, not LED, but display to keep brick count, I think that would be quite valuable as far as just like features for performance or tracking performance, like actually getting a good idea of how many bricks you pressed over time. That would be nice. Beyond that, yeah, we'll see. I mean, maybe this is going to be quite stable under normal conditions. Like right now, it was some of the coldest time around here in terms of the brick press. Like yesterday when we were actually testing it, was like around 0, and that's, you're not going to be pressing bricks when it's 0 weather, because you're not going to have soil and stuff like that. So maybe under normal conditions, this might completely work and so forth. I do believe that the single pressure sensor is great. I mean, the timing is very reliable. I know that all the people that have replicated our machine, like give you one example, one guy, the guy, Dan Schellenberg from Texas, he spent $2,000 on his controller, and of course it's souped up, it's got positional sensors and so forth. Well, ours costs $20 and I think does a great job, or no less. I think it's a benefit to have less moving parts, less parts to go wrong. So I still think the single pressure sensor is a great idea. I know the guys who are currently pressing in, there's a guy in France right now who's doing like 15,000 bricks for a big house. He's got a fully souped up system. Look at the CB Press replications, or CB Press, the replications page on the wiki. You can see the France reference. But they've got this, all these, it looks like a power plant controller with all the complications, but you don't need any of that. And that's exactly our learning. You need an Arduino with a simple relay board and a single power pressure switch, and you're good to go. So
yeah, the simplicity seems pretty good, especially considering all you need to do if you need to adjust a number or something real quick in the code is just plug in a laptop, basically. I mean, it's not.
Yeah, you can plug in a laptop. I would say that if we find out that a lot of field adjustment does have to be made for little things, then we just put, I don't know, a little input switch of some sort on the interface itself so that you don't have to have a computer out there. That would complicate things just a little bit, but we'll see. We'll see. It's, I guess, still in kind of like the final data collection, final performance testing. But this is, I mean, as opposed to, going through the iterations, the deal is that at every step we find, okay, this can be done better and that could be done better. And I would say it does matter because, for example, if you slice off $300 off the solenoid valves, or, you get the controller down to $20 in parts that can be gotten anywhere, those are all really valuable things, and I think they add value to the whole ecosystem. So, yeah, a lot of good learning.
The LCD kit, I think, looks pretty simple and quite cheap. And even with a simple little extra button or like the potentiometer knob, there may be ways to add, like you said, some control options so that you don't have to plug in the laptop. I mean, that would add more stuff in the code, but there should be a lot of ways you can add some controllable settings with minimal extra buttons or things like that.
Yeah. Good stuff. Okay, so let's move on from there. That, as far as the brick press goes, that kind of I guess in summary, I would say it's a great upgrade on a simplification of controller. So I think whoever builds it in the future, it's very easy. And then as far as the machine itself, so I like to bring up one more thing is, when I look at the machine right now, I do think I want to go through a little bit more simplification on it proper. I know that right now we can build it in a long day. I would like it even better. And so, thinking about all the simplification on the controller, on a 3D printer, makes me say, okay, let's simplify some more things. I think the way the arms and legs are, I was thinking along the route of using our standard 4x4 inch box beam tubing, which we use everywhere in tractors and backhoes and micro tractors and so forth. Very common, very useful. The 4-inch square tubing with the holes, regular hole pattern, has bolt holes already. I think it might be worthwhile to examine how that could be used for the arms and legs, or the primary and secondary arms. So I think there might be some simplification, because right now the arms, primary, secondary ones, they're just a lot of weld, very long, like 6-foot weld for 4 pieces. It's quite a bit of welding. I think we can reduce a lot of that. Use the existing holes in a box beam tubing and so forth. So I got me thinking about that, because I really see this still. I mean, after all these years, man, a lot of years. It's a decade. 2008 was the first prototype. I think there's improvements that are still being made that are going to be important for really making it accessible and easy, even than now. So I still want to see this as a really popular building method. The Smithsonian says that homes of the future will be made of dirt. That's one of the predictions. But earth is certainly a common building material, but most people live in earth homes today when you consider the whole world. So yeah, I think we can contribute to that a little more by making this thing as simple as possible. So that's kind of summary of the brick press for now. In the meantime, as I am kind of, as I'm saying, going on my semi-sabbatical to write the book, so don't plan on doing much work on the brick press right now. It's get the stable funding model on the 3D printing, including the larger printer, filament maker, infrastructure, and then really focus on a book to kind of think of it like a midpoint of OSC here at this stage, where we have the next grand call to action as a result of aligning a lot of people and sharing all the learnings to date to a broader audience in the foundational text for what we've done so far. So that's it. Okay, so let's continue here. So next updates, please. Kick it in on the 3D printer items here.
So I've been working a bit on my printer, getting ready to show it at an event, a public event. So I have a printer here in the lab where I work, and I've been working with that to print some of the parts for a new extruder.
Yeah.
How well you guys
Yep.
can't really see quality too much of this, but yeah, I think this printer is working pretty well. So I'm printing the last big part for that extruder. I have the hot end kit from E3D. I was kind of looking through that, and I don't have like the Bowden wand and the part to actually feed the filament through. So I was looking on eBay and whatnot. But I'm going to get together the part list for what I'm trying to do, and then acquire all of those parts. And then yeah, so I need some sort of handouts or signage. So I'm starting to figure out what I want to do for that. I'm thinking making just some digital like information, a digital document, and then have some QR codes so people can just pull that up. Here, I'll drop in this. So this page is.
So you're doing a modification for a Bowden style extruder?
I want to just do the Bowden style, but I didn't realize the hot end kit didn't come with that.
Mm-hmm.
So I'm just checking eBay or Amazon and whatnot to get the right parts that'll work with
Nice.
with what I ordered. But I think I think it's pretty universal. It's just based upon the filament size.
Nice. And you're at Michigan State right now,
Yeah.
and your position on that is you're a researcher right now?
Yeah.
Mm-hmm. Wow, that looks great. There's a plant research lab, open source ecology. Tell us more about that.
Well, I think they forgot a comma or something. They might not have quite got
Okay.
Yeah, so I work for the plant research lab, but I'm presenting for OSC or
Yeah.
the stuff that I, kind of do on my own.
Yeah, cool. April 5th through the 20th. That's quite an event there.
It's yeah, just one day for me for the expo.
Okay.
The 6th.
Yeah. It's pretty good. Now, on the current printer, so is retraction working for you on it?
I don't have that setting. You mean as it goes through the layers that it pulls up?
Yeah.
Yeah, I don't think I have that setting on, but I will try it with that. I've been just trying to do very simple
Yeah.
cubes. So,
Yeah, it will work without it. It's you might get just a little more stringing on the parts, which is cleanable. But yeah, that's good. That's good.
yeah, so that's some accountability to get stuff done.
Nice. Um, yeah. Great. Okay. Thank you, Eric. Um, Abe, do you have an update as well, or?
Yes, I got a little bit done on the a kind of a new clamp design for the PVC D3D Mini, and it's just a different clamp again, but I kind of made it a little more symmetrical there so that I can try to get I think that helps get the bolt length down, because I mean, that was constantly an issue to try to match the bolt length of some of the other bolts currently in the printer assemblies. So that should get it down to something. I'll have to go back and check what the existing bolt lengths are. I think it was 30 millimeter and maybe 40 millimeter. And I think the 30 millimeter, about 1 inch ones in there are obviously in there because well, they're probably shorter than that. The bolts that go through the existing clamshells for the printer axes, they're obviously short because those are 1 inch thick. So we have to bolt through those and the clamp at one point. So the bolt needs to be at least 1 inch plus, probably quite a bit more for the clamp. But by making it asymmetrical, I think get it quite a bit narrower than I expected, shorter than I expected, and I also narrowed the clamp again around the length of the bolt holes through it. So it should be smaller in some ways than the last design. I still got to add some recesses in there and see how well that fits. In general, it should work out the same in the frame. Still need to go back and check more stuff with the total assembly. It's hard to check a lot of the little details, but I think some of the stuff worked out. It looks like so that it doesn't. I've got this one so that it doesn't hit. But yeah, I think I measured the distance approximately on like the magnet holder, the limit switch holders, and those fit, I think, and don't hit anything most points. But then there's, I guess, the exact push. Let's see. I think I changed the position of the x-axis slightly on the y's, just to try to get some more space there. And I'll have to measure or just try to test assemble the extruder and some other stuff in there to see where that stuff hits. See, otherwise, I do think that that length gives the most print area. Otherwise, I think we would go down quite a bit smaller. I mean, obviously if we don't want the rods to be the same length, because that does almost seem wasteful. I mean, obviously the z-axis doesn't need to be that tall because, so that could be done differently technically, but don't care about the rod the same length. But
all right.
Yeah.
Is there a case for uniform rods amplifying the cut list? And it's useful, and a couple inches doesn't hurt, really.
Yeah. Obviously, the rods, I guess, for the bed holder, they're cut shorter as well. So I don't. They probably end up being shorter yet than whatever the z-axis could be. But Let's see, I suppose if the clamps were turned a certain way and bolted, maybe, yeah, I don't know if those rods even need to be 6 inches long for the bed holder. Because I think you said a 6-inch bed to start, and I think technically it would be really hard to get it. It'd actually be pretty difficult, I think, to get even a 10-inch bed in there. But I guess you could do an 8-inch bed. I think doesn't. There's clear space in there for that, but I know that probably takes a lot more power as well when you go to the larger bed if it's heated and all that, right? So for the Mini, that's probably not a huge concern.
Mm-hmm. Yeah. You've got so frame size. I'm seeing about, what is it? 12 inches. Yeah. That's pretty sizable. That's, yeah, decent motion there, actually, because you get that extra space by using those clamps. Yeah. And for example, I'm seeing that if you flip this clamp around, you potentially 180 degrees or
Yeah.
in the y-axis, like you could get an extra inch or two, or extra inch about. Yeah, no, that's pretty good. What's the main difference since last time? So you've changed which parts?
Well, the clamp, I made it sort of asymmetrical. You'll see that the lines no longer go across the center of the pipe. That whenever I put bolt recesses into that clamp for like the hex nut recesses in there, that should enable to be a much shorter bolt through there. I don't know what the minimum distance that'll be yet.
Oh,
but
interesting.
I don't think it needs to compress a lot. And I think that's pretty printable, I guess, on its.
Yeah, it is.
Like it should be able to print that hole okay through there, the bolt hole.
Right.
So
You just need some detail on like the head recess or a nut catcher, details like that.
So it'll need the nut recess, I think, pretty far. I'll try to see how far I think it should go in there. I think it can go pretty far in because that'll minimize the bolt length. I don't think it needs a lot of plastic strength for the compression of it, really, right?
Yeah.
That'll make the bolt a lot shorter, whatever it is. I don't know if it'll be 40 millimeters or less, but I think I measured on that and I was thinking 40 would work.
Yeah. And right now you have it set up so that standard PVC pipe can be used, right?
Yeah, that's the original frame generated with the OC pipe workbench, right? So
yeah,
it's the
right
frame. So
excellent. It's 1.04 inches. So that sounds like 3/4 inch PVC. Yep.
Yep.
Yep. Yeah. No, that's pretty cool. I like it. All it takes is FreeCAD, an OSC piping workbench, and the universal axis. Yeah, you could see how, once these pieces are well developed, this is something that a lot of people can do in elementary schools everywhere. So we can hope to get many more people involved in this. So that is good. Okay.
yeah, I've been able to make more of the files a little bit different so that they would kind of auto update with the assembly a little better. That doesn't always work sometimes, but I found a few cases finally where that's kind of helped me. Like some of the files I updated, like I can adjust the rod length, and I think a rod, and that feeds into a file that just that the axis will resize itself to any length and things like that. But it kind of has to be updated in stages to the full assembly because sometimes that stuff breaks when you go from one assembly to the next. So it's kind of like you have to have layers of simpler assemblies and then kind of intermediate sub assemblies and then the bigger assembly to do that thing. And That doesn't always work quite right, but was
Are
testing
you
some of that to see how far I could get.
are you using FreeCAD 17
No,
or 6?
no, it's just mostly, I guess in that case, what I was testing was the Assembly 2 workbench, which is known to be fairly buggy, but in some simple cases, if it's simple enough, you can make it work and it will update, and then you don't have to like rebuild all the stuff in the files. But usually for the larger assemblies, that isn't so much. But for some of like the smaller things in the sub-assemblies, it's easy for somebody to adjust one thing and it will update certain parts or assemblies.
Yeah. Nice. Abe, thank you.
Yeah, I think that's it.
Okay, excellent. Well, anybody else?
I can go. This is Nathan. I can go.
Nathan, yes.
All right. I'll go ahead and share my screen. Oh, and need an extension. 1 second. Okay, there we go. All right, can you guys see it? All right, so to accompany the size of the Meg, I just went about, I'm working on the OBI scale model. Just to accompany the size of the magnets in that link you sent me, Marcin, I had to double the size of the model. So we're basically working, instead of a 1/4 inch scale, we're working on a 1/2 inch scale. So an 8 foot high wall becomes 2 inches high, which is, or it becomes 4 inches high, excuse me. So it's a little big, but it's still workable. Still workable. So here it is. Just
1/24 scale.
What's that?
Did you say 1/24 scale?
No. Instead of 1/4 inch scale. So basically, like a foot is in the scale model is a 1/4 inch. It's a 1/2 inch scale. So basically, 1 foot becomes a 1/2 inch in the model. So
which is 1/24, right? 1 inch. Sorry, 1/2 inch to 1 foot.
Yeah, that's. I mean.
Yeah.
Yeah. I mean, in architecture speak, that's a 1/2 inch scale model.
1/2 inch scale. Okay.
Yeah.
Oh, okay.
So I just went about putting in the pockets. I think what we're going to need to basically have a fully flexible model is we're going to have sort of this many pockets for most of the modules, so that you can basically place the magnets in the areas where you need them, and then you can configure the models how you need them. That's basically to make a sort of a one size fits all sort of piece. It's not super aesthetically pleasing in my opinion, but this is kind of what we're working with now. Another option is to basically, when we assemble the set in FreeCAD, basically look for the faces that that are constrained, and then add holes kind of on that basis, sort of using probably like custom Python code or a macro or something like that. I think that would make the model look a little bit better. But then if you needed to pull apart the model, and then if you wanted to add on to it, you would have to like 3D print off new parts. So I don't know. I was hoping for your feedback on that.
Right. if I could see your screen, but I'm not seeing it, unfortunately.
Can you not?
I can't. Other people are saying they can. I don't know, bandwidth.
Okay.
Do you have on your log or anything like that too?
Yeah,
or?
yeah. It's in my log. Here, let me let's see. I unfortunately just have the model, like the file, on my log. I don't have an image of it.
Mm-hmm. Let's see.
Thanks, Abe.
Trying to open it here. What was your question regarding feedback?
So do you have the file open?
It's opening. Okay, there it is.
Okay, so basically you'll notice that there's a bunch of holes where potential magnets can go, kind of depending on the configuration of your model.
Yeah.
I mean, aesthetic wise, I mean, from a model perspective, I don't know if I really like those holes all over the place. I was wondering if instead we should look at, when we assemble the model in FreeCAD, if we should sort of analyze for, like write a Python script or macro to basically analyze for intersections, and then add the holes kind of on an ad hoc basis. I guess that like one disadvantage that I can think of, well, probably two disadvantages in FreeCAD that might be a little challenging. That's the first disadvantage. The second one being that if you wanted to disassemble the model and then kind of alter it, so if you had an add-on or something, then you basically have to reprint the new parts. So if you wanted to move a wall, say 90 degrees, you might not have connectors for it. So that would be the one disadvantage I can think of. So it's not fully flexible, but it's, yeah. Do you have a strong opinion?
Yeah. That would take a bunch of extra work upon doing the model, or if you want to put in the holes manually. Is that kind of what you're saying?
No. I mean, I conceivably I can imagine a way in which you can assemble the model so that basically, if you constrain two faces, you can run a Python script to add the holes sort of automatically. I could conceive of that. Or we could just make this sort of general one-size-fits-all model with a lot of extra holes in it that we don't use.
Yeah, they're only 3 millimeters, eh?
I mean, they're 1/8 of an inch. Yeah, so.
Yeah. Right.
Yeah, about 3 milliliters.
Yeah. Yeah. Tell me more about on the front face. You got 2, 4, 6, 8. What are the middle holes for? Is that like?
So, I mean, in my mind, it would be that if you had a 4-foot panel
Yeah.
running up into a 8-foot panel. So like if you had a window or something like that, you could attach that. And so basically like that piece wouldn't be the 4-foot wouldn't be floppy.
Yeah, no, that's good. A little variability. In fact, since in terms of 3D printing, it doesn't cost us much. We could even do more holes if needed for various flexibility, but we really have to look at use cases of how the realistic model fits together.
From most of the I'm looking at the library. It seems like most of the parts are either 4 or 8 feet. So this is kind of the minimum sort of. This is like the minimum amount of slots that I was thinking. But yeah, I mean, we could do them more frequently. Yeah, I mean, I'm open to that as well. It's a pretty trivial to add them.
Did Katrina provide all the? Do you have enough modules for?
I think right now it looks like there's only 2 there still. So
Okay,
I'm waiting on that.
Hopefully to give more guidance there. Have you looked at the Sweet Home 3D models yourself?
I have, yeah.
Is it possible for you to extract the simplification of the other modules? I mean, because all that seems like at this level of modeling, it's basic enough, or not yet?
Yeah, I mean, I can't. I think I was just waiting on her to sort of give me the latest version of all the models. She just kind of needs to point me to that, I guess. Yeah, I'll follow up with her in an email.
Yeah, please do remind her.
Okay.
That. Oh, that's pretty cool. I can see this. Just the very fact of what you have for that simple wall model, you could make, if you connect them together, you could make some fancy constructions already. Once again, a Lego block is very simple, but you can make some pretty fancy things with it. So
yep.
I think in the right direction.
Okay, so you would, I mean, taking that feedback, would you suggest leaving as many holes in it as you can? Just sort of, you make a general piece.
Yeah, it doesn't hurt.
All right.
Because
okay.
It's not like you have to drill everyone. In which case, I'd be like, okay, who's going to be doing that drilling if you're doing that manually? But if you're 3D printing, it doesn't cost you anything to do that.
Okay.
In fact, it's
all right.
Saves.
So
okay, sounds good. Okay. I'll go ahead and proceed with that route. Okay.
Yeah.
Thank you.
Thank you. Take a little screenshot here for the record. Thank you, Nathan. So, anyone else got anything for today?
I don't really. I was at the Launching a Hardware Company event last week, I guess, and there were people that were really excited about open source ecology, and we're talking about it. So that was cool. And I got kind of lost on the wiki trying to figure out which links are going where and where they're supposed to go, and that's what I've been working on. The hackathon follow-up that was supposed to be tonight got postponed because of the weather, so I don't have anything upcoming right now.
Okay. Do you need any guidance on navigating the wiki?
I will on figuring out like the header code and stuff, but I think I'm going to tag Lex with it. I think he can probably help me.
Yeah, Lex would be good on that.
Unless you got nothing but free time and it's what you're dying to do.
My ample spare time. No, I was going to focus on 3D printer enterprise.
Or sleeping.
Spare time is a little scarce right now. Yeah, sounds good.
And I followed up on the idea thing. I got an email I got an email address for who to contact, but it takes like a fair amount of like composure and thinking and getting in the right frame of mind to re-present to a homeschool program. You know, I wasn't in that frame of mind, but I'll take care of that.
Yeah. Okay. So did you establish, you had some initial contact?
Yes. Through Facebook Messenger, which is much less formal, and then I was given an email address through Facebook Messenger, but I need to figure out exactly how to present it so that I think I know who it's going to, so she doesn't feel like I'm trying to sell her something. Some of the ladies are a little more uptight than others.
Mm-hmm.
You know, it's life.
Yeah. Okay. Thank you. So I think that's about it. Some good progress. What else? Last piece of update from me would be, so on the OSC club in London, Ontario, we are still planning a physical build in April for the cordless drill. So I look forward to that. There's some progress being made on that. And it would be good to see how we can involve basically getting in a mindset of like the FIRST Robotics, real physical competitions with high school people. That would be pretty cool. Right. So that's good news. And let's see if we can get more clubs started. It happens that actually talking to the Belize people here, the guy who's the mechanical engineer, not the mechanical, the civil engineer, he's in contact with universities there. So we were starting to talk about an OSC club there for design work as well. So we'll see if that can happen. But other than that, in the planning is potential workshop this would be more in a Montreal area regarding large 3D printer as well as the filament maker. That hopefully we can make it happen this spring, if not sometime later. But that's consistent with the 3D print section, so that's kind of my thing right now. Okay. Well, so I think that's pretty good for now. Let's continue the progress. And yeah. So thank you, everybody, and I'll get some sleep here. Rest up. Today's my rest day, and get back into things, and look forward to the next meeting then. Thanks, everybody.
Thanks, guys.
Okay, and Jennifer, please send the recording. Thank you for doing that.
You're
Take care.
very welcome.